right, so our goal is to figure out what intervals this function is increasing and decreasing on. And the general idea is to study the first derivative. So we want to find the first derivative. Oh, low battery. Find the first derivative, figure out where the critical values are, find where it's zero are undefined, then see what's going on in those intervals broken up there. So let's, I gotta power through this with my iPad's gonna die. Let's find the first derivative. F prime of x. We're gonna use a product rule. We have, a function here times another function. So take the derivative of this function first. So it'll be 2 times x minus 1 to the 1 times x minus 3 plus, leave this the same, so leave that x minus 1 squared times the derivative of that function, which is just going to be 1. And let's try to see if we can clean this up a little bit. Factor out an x minus 1. So we'll have an x minus 1 times 2 x minus 3 times 2 times x minus 3 plus an x minus 1 there. We'll see if that helps. But in either case, that's our derivative equation. So we want to see where would this be undefined and where would it be equal to 0. So it's actually, like I said, just multiply this out. You go x minus 1 times, so we have 2x minus 6 plus x minus 1. 2x minus 6 plus x minus 1. So now I just have 3x minus 7 in here. I don't know why I put bracket, but who cares? Okay, so there's no undefined values because you can plug in any value for x and you'll get a real solution. And same thing in the function, there's nothing that's undefined. You can take any value and plug it into x and you'll be okay. So now let's look where the first derivative is 0, where it could be 0, where f prime of x is 0. So we're going to set 0 equal to this. 0 equal to x minus 1 times 3x minus 7. So we just solve for the zeros here. So that means that x minus 1 equals 0, or 3x minus 7 equals 0. And so we have one critical value, x could be 1. And the other one, we'll just call it x2 plus 7 will be, other one will be 7/3. So these are our critical values. So we break our interval up at these points. This function has, it's defined everywhere. So the domain will be all real numbers. So we just set up a table. I like to put the interval in the first row across. So go from negative infinity to 1. Then 1 to 7/3. Then 7/3 to infinity. If you want to see what's going on in each of those intervals, so we can, I'll pick a test point, test value. This makes it a little more organized. So pick an x value in any of these intervals. So pick an x value in here. So I'll just pick 0. X is 0. Here I'll pick, so more than 1, but less than 2 1/3. So let's just pick x is 2. And here, just pick x is 10 or whatever, anything in there. So we're going to have those as our test values that we're going to plug into the first derivative equation. So we evaluate the first derivative at 0, 2, and 10 and see what we get. So f prime of 0, we just plug 0 into here. We're going to get 0 minus 1 times 0 minus 7. So 0 minus 1, so we get negative 1 times the 0 minus 7 times the negative 7. So we get a 7. And that 7 is a positive number. So Write positive below. Now let's find f prime of 2. Plug 2 into here. So we're gonna get 2 minus 1, 1. 3 times 2, 6. 6 minus 7, so negative 1. Get a negative number, negative 1. Get a negative there, negative there. And now we just plug in, evaluate f prime of 10. So 10 minus 1, 9. 30 minus 7, 23. Can I do that in my head? Kind of. 230 minus 9, right? 221, I think. But in either case, it doesn't actually matter if I get this right. I just need to know it's positive. Because all we care is about the sign. So don't stress out too much about being precise with the calculation. Just make sure you know what the sign is. Now, if you know what the sign is, then you can talk about what's going on with the function. So f of x. What is f of x doing when it's positive? When it's positive, it's going to be increasing. So it's going to be going up. I like to draw an arrow upwards like that. So it's going up here. When it's negative, the function is decreasing. And there are no points of discontinuity. So then we can say that the solution, f of x, is increasing on negative infinity, 1, 7/3 infinity, and decreasing on 1 to 7/3. And there we go. So there's 2. Simple.